Welcome to the Aquaterra Water Treatment Plant. Grand Prairie's water treatment facility was commissioned in 1985. Currently, it provides clean, safe drinking water for the city of Grand Prairie, Claremont, and Sexsmith. The treatment plant employs 30 staff members consisting of operators, remote operators, millwrights, electrical, instrumentation, administration, and safety staff. The Wapiti River is the source water that is treated by Aquaterra's water treatment plant. Even in the wintertime, when the river is covered with ice, there is still water flowing underneath the ice cover. The raw water pump house is the building that protects all of the equipment that will transfer the water to the treatment plant for treatment. 4 submersible pumps are located in 2 wells connecting the raw water pump house to the Wapiti River. 2 of the 4 submersible pumps run to pump raw water to the storage ponds for pre-treatment. The submersible pumps push raw water to 2 storage ponds. These ponds treat the raw water, naturally settling out any heavy dirt particles. The storage ponds provide a 4-day storage of raw water in case the pumps or intakes need to be shut down for a long period of time. After treatment in the storage ponds, the raw water flows back into the pump house. Transfer pumps then take the water to the water treatment plant. There are 3 pipes buried in the ground that transport raw water to the treatment plant. Raw water enters the water treatment plant into an underground pipe gallery. A flow meter measures the volumes being pumped and provides the total volume of water flowing through the pipes to help set chemical dosages. There are 5 major steps in the water treatment process: coagulation, flocculation, sedimentation, filtration, and chlorination. After the raw water enters the treatment plant, polyaluminum chloride is added. This acts like a magnet to the dirt particles, causing them to attract to one another and form one large particle. A mixer disperses the chemical evenly into the raw water pipes, mixing it with the water from the Wapiti River. Monitoring equipment reads and records different characteristics of raw water entering the treatment plant and throughout the treatment process. One of the main terms used in water treatment is turbidity, which is the cloudiness of water by individual particles that are generally invisible to the naked eye. Turbidity is measured through shining a bright light through a water sample and measuring how much light can be passed through that sample. After polyaluminum chloride is added, the raw water then flows through underground pipe galleries into the main water treatment plant facility. A chemical called polymer is then added to the mixing tank. The polymer will gather the dirt particles together to form a heavier, large flock particle. Polyaluminum chloride and polymer pumps take the coagulant chemicals to their designated areas. Potassium permanganate can be added to the water to assist with the control of dissolved organics. Dissolved organics in the raw water will usually happen during springtime when the river collects water from decaying vegetation into its stream. The dissolved organics, if not treated, will pass through the filters and cause taste and odor issues to the water. Potassium permanganate will oxidize the dissolved organics so the filters can easily remove them. Flocculation is the gentle mixing of the raw water with chemicals added to it, causing all the small particles to form together to form a large, heavy particle. The water treatment plant has a total of 12 flocculator drive mixers. The total volume of all flocculation tanks are 1.5 million liters of water in tanks that are 15 feet deep. Once a large heavy particle is made through flocculation, the raw water enters the sedimentation tanks. The sedimentation tanks are 20 feet deep and treat 2.6 million liters of water each. The sedimentation tanks allow the heavy dirt particles to settle to the bottom. The tanks are equipped with sludge collection scrapers that gather up all the solids. These solids are piped to a valve system that will occasionally open and remove them. The solids flow into a collection tank and are then pumped to the wastewater treatment plant for further solids thickening. Tube settlers installed in the sedimentation tanks help prevent dirt particles from being lifted up and over the collection weirs. After the sedimentation process, the water on the surface is collected on top of surface weirs. The water then flows by gravity to filters for further treatment. From the sedimentation tanks, the water then flows into one of 4 filters. The filters consist of 2 different kinds of media and an underdrain system. The water needs to flow downward through this filter and is collected in the underdrain system. The first level of media, anthracite coal, has a very rough surface which will capture the fine particles entering the filter. The next level of media is very fine sand. It will further filter out any fine particles from the water. The filtered water then enters the water treatment plant's clear well. One filter will treat around 12 million liters of water before it requires to be backwashed. The filter is taken offline and air is passed through the underdrain system. This will cause the media inside of the filter to collide together, washing it of all the dirt particles it has captured. Water is then pumped from the clear well backwards through the filter underdrain system. This further washes and removes all the particles the filter has captured in treating the water. The backwash water flows into the wasting holding tank and is pumped to the wastewater treatment plant. The filter is then filled with clean water and placed back online. Hydrofloxylicic acid is added to the treated water after the water has been filtered. This is added to the water to help prevent tooth decay. Chlorine is mixed with the water and flows into the storage reservoir, mixing with the treated water from the filters. This is added to the treated water as a disinfectant if any harmful bacteria or viruses pass through the sedimentation or filtration process. After the hydrofloxylicic acid and chlorine have been added to the treated water from the filters, water then flows into a 9 million liter underground storage reservoir. The chlorine now has time to disinfect the treated water, which is referred to as contact time. After the treated water has spent time in the reservoir, it is then pumped to the city of Grand Prairie, Claremont, and Sexsmith using our high lift pumps. There are a total of 6 pumps in the high lift pump house. Using these pumps, Aquaterra takes clean, safe drinking water straight to your household faucet. After the treated water is pumped from the high lift pump house, it is redirected to Grand Prairie and different water pump houses in Claremont and Sexsmith. Each of these pump houses have its own reservoir and pumps for treated water storage and distribution. This provides the community with a large storage of water in case of water line breaks or fire emergencies. Aquaterra's water treatment plant operators monitor every process through the control room. Computers are linked to every process in the treatment plant and provide valuable data to the operators. They are able to consistently review data and make plant changes from the control room computers. Audible alarms will inform the operator when problems occur or when pumps stop working. Our operators are always testing and inspecting the quality of water they are making. They run tests involving water turbidity, chlorine, pH levels, alkalinity, temperature, fluoride, and hardness. One of the most valuable pieces of laboratory testing equipment is the jar tester. This unit lets the operators mimic the treatment plant process and further optimize different chemical dosages for the treatment plant. This is an example of what the water treatment plant will accomplish. Providing clean, safe drinking water is every operator's goal at Aquaterra's water treatment plant. Aquaterra, helping grow healthy communities.